In this video, we'll be focusing on the meaning of circumference, perimeter, and area. So I'm sure you've probably already learned about perimeter, circumference, and area, and you've probably been given formulas and said, well, this formula would get you the perimeter of this figure, and this formula will get you the circumference, and so on and so forth. That's not what I plan to do today. I plan to definitely try to get you to understand the meaning behind the formulas. So let's start off with a very simple figure. Let's start off with a rectangle. And we are first going to look at perimeter. Alright, so imagine a really big park. So we have a really big park and it goes 9 miles by 5 miles. That's a really huge park. Okay, so let's say you are here. This is you standing up here. That's your head from aerial view. And you're like, you know what? I really want to get fit. I really want to walk all the way around this park. So you decide that you're going to walk 5 miles that way, then 9 miles that way, then 5 miles this way, and then 9 miles back to where you started. Now you're exhausted. How many miles did you walk? Well, what I'm really asking you for is what is the perimeter of this rectangle. So when you think of perimeter, you actually should be thinking about the distance taken if you go all the way around a figure. So you travel all the sides. So really and truly, a perimeter is the sum of all sides of a polygon. Any polygon. It could be a triangle, it could be a decagon, it could be an octagon, it doesn't matter. So it's really just the sum of all sides. Now, you may have learned that if this is length and this is width, well, this is also width and this is also length. So you may have learned that for a rectangle, it is L plus L, so 2L plus 2W. But why memorize the formula when you understand what perimeter means? So you're really just adding the sides each time. And so in this case, perimeter of this figure is equal to 9 plus 9, so 2 times 9, plus 2 times 5, which is equal to 28 miles. So if you walk all the way around this park, you're actually walking 28 miles. So that's the perimeter of a rectangle versus now the area of a rectangle. So let's draw the rectangle again so you can see it and visualize it. Alright, so suppose it's the same park. So we're dealing with 9 miles by 5 miles. And in this case, you know that, fake grass that people lay down sometimes. I don't know why you'd put fake grass in such a big park. But imagine it with me just for a moment. So imagine that fake grass that you put down. And so you're going to that fake grass store and you're like, how much grass do you need? And you're thinking, well, this is a really big rectangle. So I need a lot of grass to put in to this area here. So you're thinking, well, can I break it up? Well, you can. So this is 9 miles going this way. So if you break it up, you have I'm trying to get this into 9 pieces here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, something like that, right? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9 miles going that way, and we have, just pretend with me for a second, this is to scale. It's terribly not to scale, but that's okay. 3. So we have 1, 2, 3, 4, 5 miles on the side. So if we break this apart into little squares, we can tell them how many squares of grass that we actually need. So for example here, this is not very much to scale, is it? But that's okay. So for example here, you could tell the people, well, I need a square of grass for over here, and that's 1 mile by 1 mile. And then I need another one for right here, and another one for here, here, here. Notice there are 5 along the side, and there are 9 columns of that. So there are really 9 times 5 square miles here. What we just did, we just found the area of this rectangle. So in order to find area of a rectangle, That's how they got the formula area is length times width. So in this case, we need 45 square miles of grass to cover that park. All right, let's look at least two other shapes, and then we can wrap up. Okay, so now that we understand what the perimeter means for a rectangle, we can apply that exact same thing to a triangle or any other polygon. So it's really just the distance around the figure. So if we were to go here, here, and here, and add that all up, we would get the perimeter. So the perimeter of our triangle here is 6 plus 9 plus 13, and that gives us 28 meters. All right, so that's how you get perimeter of all these figures. You just add all sides. All right, so now the area of a triangle. I'm sure you've heard the formula, but I'm not going to tell you the formula right away. I want to bring back the rectangle for a moment. Remember our little green rectangle with all that grass? All right, so if I took, remember that the area of our rectangle was length times width. Now, if I took my little green rectangle here and I cut it at its diagonal, I'm really cutting my rectangle in half. So now, a half of a rectangle is actually, ta-da, a triangle. So a triangle is really a half of a rectangle, which is why the area, if we had to fill our triangle with something, the area of a triangle is a half base times height. So for example, and it doesn't matter if we have a 90-degree here or if the triangle has its 90-degree angle in the middle, totally acceptable. So a base and height have to be 90 degrees to each other, but the 90-degree angle can be in the middle, and that's fine. So in this case, or formula for triangles, still the same. So let's say the base is 13. Let's actually write that a little bit better. So let's say the base is 13 and the height is 4. So again, remember the height is perpendicular to the base. Then our area is a half of 13 times 4, which will give us 26. And I didn't put units here, so if I don't put units, you could say squared units. So 26 squared units or units squared. All right, so that's a triangle. And one more shape, let's look at a circle. Okay, so we've been dealing with the word perimeter a lot, but a circle actually does not have a perimeter because a circle doesn't have distinct sides. It has something almost exactly like a perimeter though, and that's called the circumference. So the circumference is exactly the same concept. You're looking at the distance that I'm tracing here, going all the way around the circle, and then back to where you started. So that distance that I just traced in red is the circumference of a circle. Very similar, once again, to perimeter. So, cool thing about circles is that if I take the diameter, so just a reminder, the diameter is that line that goes straight through the center from one side of the circle to the next. So if I take that diameter, it actually will go around the circle exactly pi times. So it will go around the circle 3.14 something times. And that's for any size circle. It could work for a circle this small, it could work for a humongous circle that takes up the whole page, or it could work for a circle the size of the entire, who knows, really big, really small, doesn't matter. All right, with that information, we can take that and use it to measure our circle. So what do I mean by this? I mean, well, the circumference, since it fits around pi times, since it fits around or any circumference pi times, the circumference is actually always going to be equal to pi times the diameter. All right, another way of saying pi times the diameter is because there are two radii, one radius, two radii within our diameter, it's also 2 pi r. 2 radius times pi will give you the circumference. All right, So that's how you figure out the circumference of a circle. So for example, if this were 5 centimeters, our circumference here would be 2 times pi times 5, which would be 10 pi. And that would be in centimeters. So that's how you find the circumference of a circle. Now the area of a circle, similar idea. So now imagine this is some big field. We're no longer in a park, but like a circular field. And same idea with the grass. We want to cover the grass. Let's cover the circle with grass. And in order to do that, well, this one is a little bit harder to explain why it works. So I'll just let you know that to cover this area, we have pi r squared. And that will give you the area of a circle. All right.